you can take this one box, and inside of this one box, you can split it up into multiple systems, LPARs, logical partitions. And each of those are separate IPLable units that can be running an operating system of your choice. With Sysplex, you have multiple systems that are communicating with each other. So there's two ways to do that. One is with the channel-to-channel adapters, the channel being the mechanism that the mainframe uses to go to communicate with all devices that are attached to it, or through the coupling facility. The coupling facility is much more tightly integrated. And if you're connecting these systems with a coupling facility, this is referred to as a parallel Sysplex. And the main reason is it allows you to share workload. So the coupling facility owns memory, and the MVS systems that are running can talk to the coupling facility, and that you can put in the coupling facility's memory any kind of structure you want, buffers, tables, and that you can share them across multiple operating systems. And so what that allows you to do is you can have multiple that are actually working on the very same workload, so that when a request comes in, one or two or three different systems can pick up that request and operate together. And that's a parallel Sysplex. So if one of those systems goes down, you still have the other systems available to pick up work and do the work and send the results back. So that's really appropriate for transactional work like that you would do in CICS, where like a banking transaction, for instance, you might have two or three systems that are servicing transaction work coming in. A person may log into their bank and want to check their balance or whatever, and because they're sharing memory, they can have the workload mapped out in the coupling facility's memory, and each of them working on separate transactions but for the same purpose. And that gives you what's called high availability. So if any one of those systems goes down or has to be taken down, there are other systems that are still there doing the work. And so from the end user's perspective, there's no outage. They get continuous connectivity to it. There's also a part of this mechanism is the members that are the different MVS members that are sharing the system can be notified if one of the other members goes down. And you can do things like one system may be working on a particular transaction, and if the system that is working on that transaction goes down, then the other systems can be programmed so that they just pick up the work and continue it. So you can really have a super bulletproof application using parallel Sysplex. The coupling facility itself, yeah, so there are ways of using it where you can, the whole purpose is to have high availability. So you can have systems that need to be taken down or have maintenance done, like you might need to upgrade the operating system on one of them. It allows you to take a system out of the picture, do whatever work you need to do, and then bring it back up and have it rejoin that group. And it's all about having continuous availability. So the coupling facility is actually, if you look at one of the mainframes, there'll be some number of processors. So like, let's say there's 26 processors in it. So a coupling facility is when you take one of those processors, or you could use two if you want, and you run the coupling facility control code as the operating system. So if you boot up that processor with the coupling facility control code, it is a coupling facility. So it's like on board, it's one of the other processors. So instead of running MVS or VM, it's running this coupling facility control code. Then whatever memory it has, it is designed to be able to share that with the other systems. So, and starting at zJOS 2.3, the data that's within the coupling facility is now encrypted. So it's encrypted before it's encrypted by MVS before it's written into the coupling facility, and it's decrypted after it's read from it. So what that means is that the data in the coupling facility, while it's at rest, is fully encrypted. They use AES encryption, and the key that's being used for that is in the cryptographic key data set that's owned by ICSF. We'll talk about ICSF a little bit later. But the key here is that all the data in the coupling facility is encrypted while it's sitting there, and it's only decrypted once it's taken out and operated upon. The cryptographic hardware, there's two major pieces. One of them is called the Central Processor Assist for Cryptographic Function, the CPACF. It's an actual processor, and it sits on board with the CPU. So on the physical board where the CPUs reside, there are CPACFs that are right next to it, and they're specifically various kinds of cryptography. And also generate memory. The CPACF will work with both clear keys and protected keys. And in earlier systems, there was a CPACF that had to be shared with multiple CPUs. But when they decided to do pervasive encryption, they put a lot more CPACFs on the board. So now there is one CPACF per CPU, starting with Z14 and continue through the Z15s. There is a separate board, a physical board called the Crypto Express, and this is used for doing primarily asymmetric cryptography. So we're talking RSA and elliptical curve cryptography. You can configure this so that it will act as a common cryptographic architecture, a CCA, or a PKCS number 11 cryptographic coprocessor, which is a standard in the industry, or you can use it as an accelerator. This device, this board, is sealed up inside of a enclosure, and it's tamper sensing and tamper responsive. It has its own residual power, so if you pull the board out of the system, it still has power available to it. And if it detects tampering, it will basically wipe out everything that's held within it. And this meets the FIPS 140-2 Level 4 standard, which is the highest security level currently defined. Being on a separate board, it's not quite as fast as the CPACF, but the CPACF does not do asymmetric cryptography. So whenever you need RSA or elliptical curve cryptography, you have to have one of these IBM Crypto Express boards, and the control is the power is in that Crypto Express board to do that cryptography. Now, the basic zJOS services, this is kind of a high-level view of it. There's, of course, is data management for tape and disk access. These are your access methods, like BSAM and BPAM. There is security and cryptographic services. So actions like RACF to do authorization checking, that's all built in as standard zJOS. The cryptographic services themselves, the ICSF services, are part of the base MVS system. There are system management services. These are things like being able to initialize volumes, new disk volumes, be able to record information about what's going on in the system. There's network communication services, which includes both TCP/IP and SNA, and this is all part of the standard package. There are optional pieces that you can purchase. This is base. We have application enablement services, which includes various compilers like the XLC compiler, the binder, online services, which would include CICS, which is it's a purchasable item. And then there's Unix system services. This allows you to run native Unix software in an MVS address space. So whenever you have USS active in an address space, the Unix code runs along with the mix of everything else running in MVS. We have distributive computing services, and this lets you have a network file system can be mounted in zOS so that it looks local, but it's really distributed. We have distributed file services that will provide access to data that's residing on distributed systems. So with NFS, you can have native file systems on the MVS system that can be seen by distributed systems, and then we can also look at distributed file systems on distributed platforms, all from within MVS. Online business services includes the HTTP server. This is powered by Apache. It's called Liberty. It lets you run distributed type processes. You can run, I think it's called Access applications can be running in this Apache server. Also print services that allow you to distribute output, and you can even produce that output as web pages. The ICSF is the Integrated Cryptographic Service Facility. It's a started task in MVS. It used to be optional. It's currently required. So anytime you IPL a zOS system, you're going to have ICSF running, and it manages all the cryptographic keys that are used: AES, DES, HMAC keys. There's also a PKA cryptographic key data set that holds RSA keys and elliptical curve cryptography keys. There are key pairs. The asymmetric keys are interesting. The symmetric keys, it's also called secret key. So it uses the same key to do the encryption as it does to do the decryption. So you have to keep the key hidden, protected, unknown to the outside world. And if it's exposed, then you have compromised that key. But with RSA and elliptical curve keys, there's a key pair. So you use one key to encrypt it, and you use a different key to decrypt it. And that sets up a whole lot of possibilities, because then you have what's called a public key. So you can publish this key and say, here's my public key, and anybody can take your public key and encrypt data with it, but you cannot decrypt it with a public key. You have to have that private key to decrypt it. So this enables things like certificates, where you can encrypt. For instance, you can take a message, and you can get a hash of the entire message, and then you can encrypt that message with your private key, and then pass the document on to somebody else, and they can take your public key and decrypt it to see what was the hash, and then they can take that same document and run the same hashing algorithm, and if the two hashes match, it means nobody has tampered with that document. The contents of that document are preserved. So it lets you do things like that. There's also a token data set, and this is for PKCS number 11 tokens. This is just a type of cryptography that is supported. It's fairly widely used. The ICSF address space and its data sets maintain the master keys for all types of encryption. So there are in a given system a single master key for DES, AES, RSA, and ECC keys. So this master key is used to encrypt the keys that are stored in its database. There's a whole slew of callable services that are made available to call the ICSF address space to get certain things done. Like you can get a key. You can, if you've got the name of the key, you can request that key to come to you in the clear, or you can ask for it to be secure, or you can ask for it to be a protected key. And the nice thing about protected keys are that they're actually encrypted, but they're encrypted in a way that the CPACF processor can use directly. So the way that works is the key is encrypted with the master key for the LPAR, and so it's essentially wrapped in in security. That's passed back. So it's an encrypted key. It's not in the clear, but you can pass that key directly to the CPACF, and internally the CPACF can decrypt it because it can have access to the LPAR's master keys also. And in the privacy of that processor, it then gets the key in the clear and can encrypt or decrypt whatever the function is that's being requested of it. This on the security side, used to be RACF was integrated totally into this. Over the years, that evolved so that it's now kind of separated from it. Instead, they have what's called a System Authorization Facility, or SAF, and it's a callable service kind of a function. So RACF is IBM's security system, and it can plug into this SAF interface, but it also our security products can plug into it. So you have a choice if you're an MVS user to use Top Secret, ACF2, or IBM's RACF to host security. Top Secret and ACF2 are they operate on different philosophies. Top Secret is more aligned with what RACF does, and that philosophy is the person is assumed to have access to something unless there is a rule that says that or not. And ACF2 has a different philosophy. Its philosophy is you're assumed not to have access to anything unless you're given specific clearance to access it. So ACF2 is much tighter and something more aligned to what the government would want to use. But there's just two different philosophies of doing the protection. These security products, yes. So these security products are used all over the place. So it provides authentication for users and processes. For instance, anytime you log in to a system, anytime you want to open a file, the security system is called to say, can this person access this file? If you have a library, you can actually control access to individual members within that library. So this SAF system has intercepts everywhere. There's a rack route macro that gives you callable functions, and if you issue the rack route macro to request security for different things, it can be for files or commands, like for the Datacom database. Each command that you can issue to the MUF is protected by RACF or ACF2 or Top Secret. So at the command level, it's however you want to use it. It's just you make the rack route calls in your product, and when you call rack route under the covers, it will invoke either RACF, Top Secret, or ACF2. It's just a generic way to access those systems. And of course, any console command you issue via sysview or from a native console, every one of those commands is protected with RACF, and you're either authorized to issue them or you're not. And you may notice that, like on our systems, if you're on, there's a whole lot of things you cannot issue command-wise that you can on the other development systems. And that's all through the rules set up in the security system database. Okay, so SMS, Data Facility Storage Management Subsystem, just SMS for short, is a huge area. It has to do with all the storage that's attached to the box, both disk and tape. So there's a component called Data Facilities Product, DFP, that as part of that, it is all of the access methods, BSAM, BPAM, QSAM, and EXCP. And plus, there's a whole raft of system services that will manage disk and tape. You can access and update the catalog, the VTOC, the volume table of contents on disk volumes, updated, managed. You can it's basically gives you the ability to touch and update everything that's on disk or tape everywhere. There is a facility called Data Set Services, DSS, that's a utility that allows you to orchestrate backups and restores. You can move data sets from one volume to another. You can volume SMS to SMS and vice versa. It's a utility that allows you to manipulate data at rest on various devices, mostly DASI devices. There's a hierarchical storage manager, HSM. This specifically looks at inactive data or low activity data, and based on whatever rules you have in place, so you set up rules in your SMS storage or management classes, and the HSM or an equivalent like CA disk or CA ASM2 will look at how long a data set has been sitting inactive, and based on the management classes, it will move it on to a lower performing devices. For instance, it's been on disk and nobody's touched it for 60 days, so it moves it to tape, or it moves it to a compressed disk storage. And the longer it sits, the more it gets moved to slower and slower devices. But then if anybody tries to access it, it also provides transparent intercepts, so that if a program tries to open a data set that's been archived, it will kind of suspend that program and pull it off of tape and put it back on disk. And then once it's restored to disk, it will allow that process to continue. So as far as the process is concerned, it's trying to access it. It's transparent. It does get suspended, but it doesn't know. It just thinks it's opening a data set. And by the time it's unsuspended, the data set's there and it moves on like normal. They provide a removable media manager, which is tape. And of course, we have CA1 and CA-TLMS that provide this service. They plug in and replace RMM. This manages tape data sets, and of course, tape is different than disk. It's much slower to access, much slower to for the open to happen. But once the open is completed, the data is available very quickly, because the head's always in the right place for sequential processing. You can stack multiple data sets on a given tape volume. So these tape management systems have to track all the secondary files that are on the tape and provide services. For instance, if you have, let's say you have 1,000 different data sets on a tape, and those expiration dates that are associated with those data sets are very different. Over time, data sets will expire on that tape, and you end up with the tape containing a lot of data sets that are active and a whole lot of data sets that are not active. And so these tape management systems will also provide a facility to copy active data sets off of that tape onto a new tape to consolidate them, and then free up the tape that was not utilized very well because of so many expired data sets on it. That's all in the realm of the removable media manager, CA1 TLMS. There's a transactional VSAM service. This allows CICS transactions and batch jobs to run concurrently at the same time. They can update the same VSAM data set at the same time, and so it facilitates the sharing of data sets and provides record level locking and prevents double updates. That's all part of DFSMS. So this whole area of data set encryption, this became a really big deal with zJOS 2.3 when they had pervasive encryption. And this is a relatively new feature. And in general, it's a transparent encryption. So for VSAM, QSAM, and BSAM, you really, as an application programmer, you don't really worry about the encryption. It just happens automatically. But EXCP is a different story. EXCP is not supported transparently. So you have to go through hoops and all kinds of gyrations to make it work with EXCP. Our database products and a number of other storage management products we have are EXCP based. So this has been a huge issue for us. The encryption uses AES 256, which is currently for most, I guess, the most effective symmetric key compression, encryption. So the data set has associated with it the key label, which is the key name, actually.
The key label is stored in the VVDS record associated with the dataset. So when you open an encrypted dataset, if it is VSAM, QSAM, or BakerSAM, the access method will get the key label from the VVDS and go to the ICSF system and get the key, and will then transparently decrypt or encrypt the dataset as needed.
There's a health checker system in what it is a framework that supports various components providing their own health check services. So this is designed so that if a given component is looking at how it's been configured, and it can say, well, you know, I'm not configured right. It's a mechanism for that component to put a message into this health checker system, and the health checker will run this unit of work, and you can do things like if it's got a data set that's nearly getting full, then it can report an exception like my data set's getting full. And the cool thing about this is that on the CA health checker, we provided a way for the products to redrive these health checks. If they want to change a parameter, the actual program that changes the parameter, once it updates the parameter, can issue a command to redrive that same health check. So if you go and fix the problem, it redrives it and will instantly switch it from being in an exception state to being in an okay state. It's really pretty cool. zJOS MF is a relatively new component that provides a way to manage workflows. So we create workflows, and those workflows can do the installation, and they can also do maintenance, and they can manage the configuration of the products. So there's really no limit to what you can do with the workflows. We will the primary way we do this is we build the workflows in-house to do various things like install and configure, and then we ship that to the customers, and then they will run zJOS MF workflows at their shop to perform those functions.